Hello friends, welcome to Global Azure Bootcamp 2021 online series where more than 400 speakers share their insights with you to help you leverage the power of Microsoft's public cloud and other products. In this session, I'll be reviewing a few different ways you can store, manage, and run your containers in Azure to bust the myth that the only way you can run is through container instances or Azure Kubernetes Services. So if you're ready, buckle up and let's start our journey. Containers are getting widespread day by day. Organizations are using containers for everything from small projects to mission-critical 24/7 applications with 999, 9999999 uptime SLAs. Now, I don't know how many times was that, but you need to just keep in mind that containers have helped companies to keep their applications up and running for a really long time compared to traditional ways. These kind of projects have all the myriads of different requirements and drivers that go into making the decision of where and how to run containers. But before we go into more details, let me tell you a bit about myself. My name is Yas, an Azure technical trainer based in Melbourne, Australia. I'm a cloud solution architect, a software engineer. I do publish courses on Pluralsight. I do a lot of public speaking, especially internationally. And I also like to write great content for you. Before we jump into the topic of what is available today, I need to give you a bit of a background about what we had before. Containers on Azure started off with a fairly basic offering. It was called Azure Containers Services. It supported what at the time was considered to be the cutting edge of containers for orchestration, namely Docker Swarm and DCOS, or Distributed Operating System. And short of that option, there really wasn't much else. This quickly changed when Microsoft doubled down on containers. Now the bet has paid off, and we have matured well beyond this initial offering to become a leader in the containers as a service amongst all the other cloud providers out there. In order for you to work and manage any container in Azure, you need to have a repository for your container images. Docker Hub is an option, but you need to remember that Docker Hub is not hosted on Azure, and it might take a bit of a while for your containers, for your images to be pulled down, especially if they are big. Now, Azure offers its own service, and it's called Azure Container Registry, or ACR for short. ACR is a blob storage-backed container registry as a service. It allows you to host your own images as in either public or private repositories. It also has integration with third parties, which allow you to scan your images for security purposes and the ability to integrate with other services through webhooks so that automation can happen when new images pushed to your registry. ACR supports geo-replication of images to ensure container images are highly available regardless of which Azure region you're using. You can use Azure Container Registries with your existing containers development and deployment pipeline, or just use this task to build container images in Azure. ACR helps you to build on demand or fully automate your builds with triggers such as source code commits and base image updates. Let's have a look at a few use cases for Azure Container Registry. The very first one is that if you need to have a private image repository, ACR is what you should be using. It allows you to have seamless integration with AKS, Azure Container Instances, App Services, Azure Batch, and Service Fabric by default. So really great if you are using one of those services, and we will have a look at a few of those services in our upcoming slides. If you wanted to have security audits on your images, ACR is a great option for you. It already has built-in integration with third-party services which allow you to scan your images for vulnerabilities or things that you shouldn't be having in your base images. And at the end, it allows you to have integration with developer tools such as Visual Studio Code, and heaps of other tools that are there out there. Enough talking. The best way for you to see how easy it is to set up and use Azure Container Registry is by going through a demo. So if you're ready, let's jump into Azure Portal and create our very first Azure Container Registry. Alright, so we are in the Azure Portal, and I already have a resource group which is called ATT Bootcamp. Next thing I need to do is to click Add the new resource and search for Container Registry. I can select Container Registry and click Create. All I need to do here is specify a name. Remember that this name should be unique because it will be part of the URL, which is the name of that container registry. Next thing, you need to provide a location and then the pricing tier or SKU. Now the difference between different pricing tiers is all the different options that you get. For example, with Premium, you will have support for networking options or integration with virtual networks. You will have different options for having customer provided keys or BYO keys with the encryption options, and more storage and also more capabilities. I just select standard and click create. Now we'll speed up the video until the deployment is successful, and then we can come back and deploy our image. Alright, so it seems like it's finished. I can click on go to the resource, and all I need to do is grab the name of that Azure Container Registry. Next thing I wanted to do is to bring up my terminal, and we wanted to push an image into this container registry. So the very first thing I need to do is to log into this Azure Container Registry. So AZ, I'm using Azure CLI, and I've already logged into the Azure portal using this terminal. So AZCRL login, I'll provide the name, which is the one that we just copied. Just keep in mind that you need to have Docker for Desktop running, because these commands will use Docker. Now the next thing we wanted to do is to either create an image or pull an image from one of the repositories. So what I want to do here for brevity, I just want to pull an image from one of our Hello World images from Docker Hub. That image is now saved, and now what I need to do is to tag that image. So what I can do is just do Docker tag, specify the image, and then the new name for that image, it's going to be the name of the full URL of my Azure Container Registry plus the name of the image and a v1, which is the version of that image. Once after the tag, I can then push this image into my container registry by using docker push. And now this image is being pushed to our container registry. Because the image is small, things happen super fast, and I can see that this image is now part of our registry. So you see how easy it is to set up an Azure Container Registry and push our image into it. We can reuse this image later on when we go through the rest of our session. The next service I want to review is Azure Container Instances. ACI is a service which enables the developer to deploy containers on Microsoft Azure public cloud without having to provision or manage any underlying infrastructure. This service, which supports both Linux and Windows containers, eliminates the need for a developer to provision a virtual machine or implement a container orchestration platform, such as Kubernetes, to deploy and run any containers. Instead, With Azure Container Instances, an organization can spin up a new container in no time via Azure Portal or command line interface, such as Azure CLI or Azure PowerShell, and Microsoft automatically provisions and scales the underlying compute resources for you. ACI supports standard Docker images. A developer can pull from one of the container registries, such as Docker Hub or the Azure Container Registry that we reviewed in the previous slide. Some of the great features of this service include public IP connectivity, so you can access your containers through a fully qualified domain name or an IP address. You can also customize how many number of CPU cores or memory do you want for your containers. Container instances are stateless by default, but an organization can choose to mount an Azure file share to a container to enable persistent storage, which is great. And at last, but not least, which is one of my favorite, is that you can run one or multiple containers in a container group, which share the same host machine, storage, network, and other resources, but it's beneficial when you want to split one functional task among several container images. For example, a container group can include one application container and a database container or a monitoring container to run on the same container instance, which is really great. So let's go and review some of the use cases for container instances. If you wanted to have a look at the use cases, if you wanted to run a single container in Azure, there is nothing better than Azure Container Instances. If you don't need any integration with services such as VNet integration, again, this service is for you. If you want to run multiple containers in a container group to allow them to share the same infrastructure, interact with each other in a safe manner, and etc., you will need to use container instances. So without further ado, let's jump into a demo and see what is container instances and how fast we can spin up and run a container on this amazing service. Alright, so we are in our Azure portal and already in the resource group that we have created for this session. I can create and search for container instances. Just need to provide the name for our container instance. So let's say this is ATT Bootcamp ACI. We provide the location, can provide one of the pre-existing images or the image that we just created from our container registry, the hello world. You can see that the V1 is here. I can change the sizing. I just leave it there and click create, and that should be enough for us to get started. Now I could have provided a fully qualified domain name, but for the time being, I don't want to do that to make this a bit more quicker. This might take a bit of a time, so I'll speed up the video and we'll be back with you once this is finished. Alright, so it seems like our deployment is complete. Let's go back to our container instance, have a look at the containers. You can see that the hello world is up and running. And what we can do here is come and grab our public IP address and paste it in a new window to see the container running. So here it is. This is our container instances demo image, and our container is already up and running. So let's continue with the rest of our services. Next up, we have web apps for containers. Web apps for containers leverage the Azure App Services to run containers in the context of those apps. These containers have all the features of app services, such as auto-scaling, scaling up and out, just like Azure App Services do. Likewise, these can be easily integrated with other features through Azure App Services like VNet integration, Azure Application Insights, and all the other services that are available out there. Web apps for containers support for multi-container applications which can be defined using Docker Compose YAML files or also Kubernetes resource files. If you are running your containers on Azure App Services, you have the advantage of auto-scaling and load balancing just like web apps do. With Azure App Services, you can automate and simplify your container image deployments through continuous integration or continuous deployment capabilities with Docker Hub, Azure Container Registry, Visual Studio Team Services or Azure DevOps, and also GitHub. App Services create an association with the selected repository of your choice, and web apps are updated each time your source code changes. So really great features there. You also have the capability of scheduling performance and quality tests in the staging environment using the deployment slots and swap the staging with production in seconds, or even roll back to previous good version without any downtime. If you wanted to have a look at a few use cases of Azure running containers on app services, is that the first one is you can host your container as web apps on Azure really easy and in seconds. If you need auto scaling and load balancing, you should use Azure App Services over other services such as container instances. You can deploy your images in seconds using integration with Azure DevOps, GitHub, Azure Container Registry, and Docker Hub. And also, if you want high availability, you can leverage the features of Azure App Services to run your containers in multiple regions and keep the user really close to where your application is. And at the end, built-in integration with a lot of different services such as application insights and analytics is really great choice for you if you wanted to monitor your containers really close. So let's go through a demo and see how we can deploy a container into Azure App Services and how much does it take compared to container instances. All right. So here I'm in Portal again, and this time I wanted to add a web app. I select the web app and click Create. Now I need to give it a name, and the name should be unique. So we'll call this HTTP Bootcamp 21. Hopefully that's unique enough. And instead of code, I use Docker container. This could be a Linux. That really doesn't matter at this point. I will choose my region. I will choose my app service plan. Select the new app service plan name. And for the size, I'm going to reduce that to standard. All right. Next, I want to configure my Docker. So this is a single container, and for the image source, I want to point it to my Azure Container Registry. Now I've already pushed another image just to give things a bit of more excitement. So I will click Create and wait for this app service to get deployed. Again, I will speed up the things through the magic of video and we'll be back with you shortly. Alright, so it seems like our app is now deployed. I can come and have a look at the fully qualified domain of this app, and when I click on that, it will then start my container, and we can see that the app is up and running successfully. Now again, the first time it might take a bit of a time, but we just need to be a bit more patient. I'll speed things up and we'll be back with you shortly once the app is up and running. And you can see the container is now up and running, and we've successfully deployed this container. So let's move on to our next service. Our next service is Azure Batch and Batch Shipyard. Azure Batch, as you might have known, is a service which lets you run long-running tasks or batch jobs on dedicated compute resources. Batch Shipyard is an add-on on top of Azure Batch which allows you to run your workloads inside a container. This enables a whole heaps of new possibilities for you to explore. It also allows you to provision the containers with all the needed software, then simply pull the container when the job starts rather than having to build out the environment before, and batch processes can then be run afterwards. So really great service to allow you to run your long-running tasks inside containers. One of the things that is really great with Azure Batch and Batch Shipyard is that it allows you to have automated, integrated resource monitoring with Prometheus or Grafana for batch pools and remote FS storage clusters. It also supports Batch Insights, which is one of the insights such similar to Azure App Insights, but this time for Azure Batch. Now, if we wanted to have a look at a few use cases for Azure Batch, we can see if you wanted to run big data workloads, Azure Batch and Batch Shipyard is for you. Reporting is really great if you wanted to have all sorts of different reports to be generated within your containers. If you want running tasks to be run within a container, Azure Batch and Batch Shipyard is for you. CPU intensive processes also are really great candidate for Azure Batch and Batch Shipyard. The next service we're going to cover is Azure Service Fabric. Azure Service Fabric is a homegrown microservice framework which has its own model for running microservices natively written for Service Fabric, as well as the ability to run containers. Now, Service Fabric engine provides orchestration and monitoring, scaling and healing for services running on Service Fabric. You have the ability to deploy container images and activate them. You can do resource governance, including setting resource values by default. On Azure clusters, you have the ability to perform repository authentication using Service Fabric. You can map the port to host port mapping, which wasn't available with Container Insights, for example. You also have container-to-container discovery and communication by default enabled on your containers when you run them inside Service Fabric. So really great service for you to explore. Now, when it comes to running containers in Service Fabric, you can see that all of those run on something which is called nodes. Now, these nodes are the exact VMs underneath which are powering the compute, the necessary compute power for your containers. Now, sometimes these nodes have the same configuration, or they could be coming in different configuration. It's really up to you how do you want to manage those. But you can leverage a lot of different services such as load balancers or security features, Azure AD integration, or you can talk to other services such as Cosmos DB or SQL Server if you wanted to perform backend type operations. A couple of use cases for Service Fabric or running containers within Service Fabric is mainly around IIS lift and shift. If you had applications running on premises on IIS, it's really a great way to lift and shift them into Azure using Service Fabric. If you wanted to mix your containers with if you already have services running in Service Fabric or microservices running in Service Fabric, and you wanted to mix them with containers, a really great feature is there for you as well. You can reduce the impact of noisy neighbors in your environment using this amazing feature. Now, the next service we're going to cover is Azure Kubernetes Services, or AKS in short. AKS is the flagship container offering on Azure. It is a fully managed Kubernetes and standards-based implementation that integrates well with other Azure services such as Azure Virtual Networks, load balancers, application gateways, file storage, managed disks, and blob storage. This really makes AKS the best-in-class offering for hosting all kinds of different applications, from web apps, databases, caching clusters, and numerous other options. Creating an AKS cluster is really easy. Scaling it up and down is simple. Scaling it out is even simpler. All you have to do is pay for the compute nodes, and everything else is managed by Azure Containers Kubernetes Services. It's available in more regions than any other cloud service provider out there at the moment. It's faster end-to-end development experience. It allows you to integrate directly with Visual Studio Code through Visual Studio Code Kubernetes tools. It has built-in integration with Azure DevOps and Azure Monitor for monitoring all of your services which are running within AKS. Now when it comes to deployment to AKS, there are multiple different options from GitHub and GitHub Actions to Azure DevOps, but that's not the only case which is good for using AKS. You can integrate AKS with Azure Policy to perform compliance check before running your containers from your container images. This makes the Azure Kubernetes Services one of the most secure services out there to run containers within that service. Azure Kubernetes Services is available at more than 42 regions at the moment, which again, as I mentioned before, it's one of the advanced or one of the most accessible services within not just Azure, but also other cloud providers out there. You can orchestrate any type of workload running in an environment of your choice. Whether you want to move your .NET applications to Windows Server containers, or modernize your Java application in Linux containers, or run microservices applications in a public cloud, at the edge, or in hybrid environments when you have hybrid connectivity with your on-premises environment, all of that is there using this amazing service for you. We wanted to have a look at a few use cases of AKS. You can say that lift and shift operations of the containers, if you already have containers on your on-premises, lift and shift of those into Azure is super simple using AKS. You can simplify the configuration and management of microservices-based applications using Azure Kubernetes Services. Bridging or bringing DevOps and Kubernetes together is also possible using AKS. And containers within AKS. Alright, so we are in Azure portal again, and this time I want to add a new Azure Kubernetes Services. And click Create, specify a name for our cluster. So let's call this ATT Bootcamp again. We choose the Australia East. If your region supports multiple zones, you can have availability zones available for your nodes as well. Your primary node, I can reduce this to 1 for this purpose of this demo. You can also change the sizing of your VM, which supports your nodes. You can also have a look at your node pools, enable virtual nodes if you wanted to leverage the Azure container instances for rapid bursting. Authentication methods, a really great set of features there. Integration with VNets. You could leave that as Kubernetes or Azure CNI. I will leave that as Kubernetes for now. And also, if you wanted to leverage the Azure Container Registry. So I'm just going to create this for now. And I'll speed up the video. We'll be back with you shortly once the resource is created. Alright, seems like the resource is deployed. So let's go and have a look at that and get some information before we can continue with this. I can see that the API server address is listed for you here. And at the moment, we have our node pool up and running. But what I want to do here is now going through the portal. I want to bring up Azure Cloud Shell, which is a browser-based terminal which you can access Azure CLI or Azure PowerShell commands. Now the very first thing we need to do here is to authenticate with our Kubernetes cluster. So I just paste the command. This is like AKS get credentials and then passing the name of the resource group and passing the name of the AKS service. Once we've authenticated with our AKS, we can then run kubecontroller commands such as kubecontroller get nodes, and that will bring up all the nodes that are available through this AKS instance for us. Alright, you can see that our node is up and running. Now what I wanted to do is show you what we are going to deploy in this AKS instance. So what I have here is a YAML file which outlines two services that we will want to deploy into this AKS cluster. We have an Azure Vault backend, which is leveraging Azure Redis cache, and the other one is a front-end application which is written to add votes for different animals and write that into the backend application. So this is using the Azure Vote front-end image from this repository. You can see that we have the CPU usage, we have the memory, we have limitations, and so on and so forth. So let me close the editor, and what I wanted to do now is to use the same kubecontroller commands and deploy this YAML file into our AKS cluster. Alright, so we already have those deployed, and we can use the watch command to get the status of the running services within our cluster. You can see that the external IP is already assigned, and if I wanted to come here, I can open a new tab and wait for my container to be up and running here. This watch command will tell us when this is ready, and once that's ready, we could come out of the watch command and wait for the app to come up. I'm going to speed up the video, and we'll be back with you shortly once the application is up and running. Alright, so our application is up and running. You can see that I can vote for dogs or cats. I can reset the counts. Let's vote, and to prove to you that these numbers are written to that Redis cache that we saw, we can get this, close this application, open it up again, and see that these are persisted. So this is how easy it is to deploy one or multiple containers within your AKS instance and leverage this powerful service for you. Let's move on to our next service. So let's move on to our next service. Our next service is Azure Arc. Azure Arc is a service which was announced at Ignite 2019. Arc is not so much of a platform for running containers as it is a set of tools which allow you to extend, operationalize, and manage multi-site setups that extend beyond Azure, such as your on-premises data centers or into other cloud providers. Arc can manage Kubernetes-based applications on these extensions. Azure Arc offers simplified management, faster app development, and consistent Azure services. Standardized visibility, operations, compliance across a wide range of resources and locations by extending the Azure control plane is just one of the few benefits of using Azure Arc. You can build cloud-native applications anywhere at scale, code and ship applications from Azure to any Kubernetes distributions in any location. You also have the ability to get Azure innovation and cloud benefits by developing Azure data services on any infrastructure and securely build and train machine learning models anywhere. So really great features from Azure Arc. Wanted to have a look at a few use cases. We can manage multi-sites, as I mentioned before, using Kubernetes through a centralized management system. Ensure consistent deployment and configuration of nodes and clusters. Regulatory and sovereignty requirements. And these are just a few use cases for Azure Arc. The last service we will review is Azure AKS Engine. AKS Engine is the secret sauce behind our AKS. Microsoft has made the same engine used to deploy AKS on Azure as a service available to all the users out there. AKS helps ease the creation of a container cluster on virtual machines running on Azure by automating the process. AKS Engine is open source. Everybody can contribute to it, and it is managed by a really strong community. One simply needs to define the cluster's parameters and leave the rest to AKS Engine. AKS Engine allows you to run your Kubernetes cluster on your data centers and even on other cloud providers. So really great service which allows you to have, for example, your AKS Engine running on Azure Stack Hub or on your on-premises environment on a set of virtual machines. You can leverage Traffic Manager. You can leverage integration with CI/CD pipelines, Azure Container Registry, and a lot of different services which allow you to work with Azure Kubernetes through the AKS Engine. Few use cases for this service, we can point out that if you need AKS's features, but running containers is in Azure is not an option for you, then AKS Engine is the way to go. If you wanted to manage Kubernetes clusters on Azure Stack Hub, again, this service is for you. And with that, we come to an end of this session. I have shared many different ways with you that you can run your containers right from Azure Container Instances to Web Apps for Containers, Azure Kubernetes Services, and so on and so forth, and show you how easy it is to get them up and running throughout our demos. I hope you've enjoyed the talk and wish you all the best in your containerization journey.